Yeah, I'm sure that if I just stand on these, if we have to, I can grab a come along and get some tension.
Oh.
Hang on a second. The jack, I think I gotta push the jack because it slid on the jack.
Oh, it did. Okay.
Yeah.
Well, it's still under. This thing is still under it, just not.
Okay.
So if anything does happen, it should.
Okay. Yeah.
Yeah.
That's definitely better. Hang on.
Yeah.
It's not, the jack is not rolling with it.
I think we're still okay.
Oh, you want to just slide it on that thing?
I think it's yeah.
Okay.
The only thing is these 2x4s are moving now too.
Or okay. Well, you're on the trailer, so if anything happens with those, you should slide. You know what it is.
Just be careful. Yeah.
So last night I went and picked up some things, one of which I've needed for a while. And you guys have told me so in the comments many times. Well, I have listened.
So as you can see, I picked up a lathe. I was going to get something a little bit smaller to start out with because I have absolutely no idea what I'm doing. But this should be able to do something up to 3 feet long and I think 14 inches wide. I don't have a lot of tools for it. This is really all I got. And the tailstock only has a chuck for a drill. So we gotta find some parts for this. This is 3-phase, but they make it easy with these digital phase shifters. Basically what that does is takes split phase 240 volts and turns it into 3-phase. But it's really just to start up the motor, and then once the motor's turning, it actually produces its own third leg by induction. So those things are pretty cheap. They're like $120. It's really not true 3-phase, but it'll work. So I want to mention again that I have absolutely no idea what I'm doing with this thing. I just played with it for 5 minutes to see what does what, but really getting set up and getting something turned down, I don't have a clue. So I don't know exactly what year this was produced, but I'm assuming it's sometime in the 70s, which sounds really old, but some of the lathes that I was looking at were from the 20s, 30s, 40s, 50s. So this one being gear driven instead of belt driven is something that I wanted. So this is about the oldest machine that I would accept. I paid $1,500 for this. I do have a lot of parts that I want to make. I may not get to make a whole lot of them in this video because I'll be learning. And I also don't have materials yet because I don't know exactly what material I need to make things like pins and bushings. I have an idea, but I want to kind of confirm. And I want to warn anybody that works in a machine shop, there's going to be a lot of cringeworthy stuff that I do in here. Like I said, I have no idea what I'm doing. You know all the different things that I do. So for me to get involved in this, it's a good thing because I need it. But at the same time, I do so many other different things that you can't really blame me for not knowing what I'm doing. I've been watching videos on YouTube to kind of get a start on what to do and what not to do. But people that work in a machine shop, they are very, very particular about how things need to be done. So we should have some fun and learn some stuff. Maybe you guys will learn some stuff. I'm sure I'll learn some stuff. And hopefully by the end of this video, we'll make some parts and put them to use. So recently I started looking around for just scrap steel that I could use in this lathe. Some to practice with and some to just have on hand for emergencies. So I have this pin that I got off of one of my excavators. This is, I don't know, 3.5 inches wide or so. I think it was 90 millimeters if I'm not mistaken. And then I also ordered some on eBay. Like this piece right here is 6 inches wide and almost 3 inches tall. That's 1045 steel. I got some 1141 steel, which I don't know much about 1141. And then I also went to my local steel yard and they had a scrap bin. And in the scrap bin they had this, which is, I think this is 3 inches wide. And it's $1 a pound to buy that, so that's a steal. That's great to have on hand for stuff. And then I also got this, which I think is 2 inches, maybe 2.25. And then I just have various other pins from machines that I took out. That was it's just all scrap stuff. This is king pins for a truck. I even have like input shaft and some just random collars that I had. I also got a brass bushing here too that is a little oversized so that you can turn it down. This is for one of the telehandlers. And then I also have just some DOM here too. But yeah, and I mean I have just like so much stuff, and this is probably about a third of what I have altogether. I gotta gather it all up. It won't fit in this area, but I figured I'll put some of it here just for things that I can grab quick, especially for practicing. But like I said, also for emergencies, like on the weekend if something happens and I just need to rebuild something, or even for making stuff like a collar to press something. Like I'm going to be building a pin and bushing puller and pusher. I already have gathered some of the parts for it, but for that I will need random pieces that will be able to push and pull bushings and pins, and they'll all be different sizes, and I'm sure I'll have to make them on the spot as I'm working on projects. So it is definitely good to have stuff like this for that. Especially having stuff like this, which is probably mild steel, like A36. That may not make a good bushing or a pin, but it would definitely make a good collar or just something to push or pull something that may be a one-time use. So I think one of the first things that I could make on this lathe is going to be a part for one of the telehandlers that I knew it would cost $300 to $400 to have a machine shop make it. Making it here will not only save me $300 to $400, but also it's an hour there and an hour back. So I figured it would take me less than an hour to make the piece and almost free. So on the second telehandler that I haven't worked on yet, right there, that eyelet is missing a bushing. And what's weird about these machines is a lot of these bushings are brass. You can see that one is brass. That one needs to be pushed back in, but it's only like a quarter wall brass. I'm not really sure if that's correct or not. All I can do is see the part number for it, and then I can order the part, but I can't see what the part is made out of. And I don't want to order the part. So to give you an idea about this location, this cylinder right here never sees any wear. There's never any kind of force on this cylinder. All this does is direct fluid to the carriage in the front. This is just a slave cylinder so that as you're raising the boom, it levels out the carriage. So like, imagine this is the boom. As it's going up, the carriage on the front is staying level. So all it's doing is pushing fluid to the carriage. There's never any force exerted on this cylinder. So you could literally make that out of wood and it would probably be fine. But we'll probably make it out of something like mild steel, or maybe just a little harder than mild steel, and it will definitely be fine. I don't know why it's not there. I'm assuming it just fell out. Obviously it didn't get worn out. The hole is not oblong and the pin is not worn out. I think it just sort of fell out. either they took the pin out and then didn't put the bushing back in when they pushed it through, or it just popped out. Maybe there was just nothing to hold it in. I see that somebody welded on the end of this pin. I'm not sure what that's about, but in any case, we can make this piece up, no problem. I'll bet you the pin is 2.5 inches and the bore for this eyelet is 3 inches, I'll bet you. Okay, so the pin is 2.472. 2.484. Let's see, so the most is 2.49. Let's see, 2.490. That's gonna be the most. Yeah, so we'll just consider that like 2.5. Like 2.5 is totally fine. And then the bore, it's kind of hard to measure. It's kind of hard to measure the bore, but let's just see here. Yeah. Yeah, so I think the bore is going to be 3 inches. So we want that to be a press fit, but at the same time we don't want to struggle like crazy getting it in there. So what's unfortunate about this situation is my scrap pile here, and even the scrap that I don't have here, I checked everything, and I have these pieces here, which would be perfect, because these are like 3 1/4, so I could turn it down to 3 inches, but it's not long enough to put on here. So I'm sure I could maybe weld on a dowel. Maybe the first thing I could do is start boring it and then put in a dowel, press fit, and then tack weld it, and then it would stick out enough where I could machine it. But at the same time, you know, actually I just thought about something. If I bore it out first, then I can grab it from the inside and machine it. The other option is to take this pin and cut it down and use that, because then I could just cut it longer than I need, and then I can do everything without having to flip-flop it around so much. But I don't know how it's going to be to cut this. I need to look for a nice bandsaw, like a big stationary one that has like a power feed. That way I can just sort of set it up and come back in a little while and it's cut. Like, I have my cold saws, but I don't know, I might go through a whole blade just trying to do that. I also don't know how hard this is, so that cold saw might just peen over the teeth immediately. That's a pretty expensive process to do that. Yeah, because that leaves me just enough. It's like 3 1/8. That's plenty to get that down to where I need to on the OD of this. Let's try doing that. Well, I mean, what do we have to lose? This piece cost me like $5. Okay, so I got a quick change for this boring bar because this is a 3/4 inch boring bar, and all the other stuff that I run is 5/8. I probably should have just got 3/4 for everything. That way I don't have to switch them back and forth. But when you go from 5/8 to 3/4, you got to set the height. So rather than set the height each time, you just get another quick change, and the height is already set on it. So that way you just kind of go like this. And now the height is set. Just gotta adjust the angle a little bit. Now with a 1-inch bit going through there, it just leaves enough room for this 3/4 inch bar to go through. You wouldn't want to be any less than that though. .48. I'm gonna slow my feed down so I end up with a little bit better of a finish. Ooh, a little too deep there. Luckily I have a little bit to play with here. Yeah, I'm about 10 thou too much. but I don't know. I want a nice slip fit. I don't want a press fit. Actually, you know what? That's only for that first little lip, like the first 1/4 of an inch of it. The rest of it is, I'm only 5 thou under. About 120 thou I need to take off. That's right at 3 inches and 12 thousandths. right? So, I guess I took a little bit too much. About 5 thou under my target. If I really wanted to be complicated about it, I could weld this up, but I just don't think it's that big of a deal. So now I think we'll chamfer everything to make it easier to install this. That's 2 inches and 152 thousandths. So I could take about 150 thou off that. So I'll just keep facing this until it's right at 2 inches. Let's see if we can fit this on here without too much disassembling or anything. I don't know though. Probably not. Well, that looks good. Hey, look at that. Hey, that is awesome. Hey, look at that. Oh, okay, well, I told you I was a little bit under on the OD, but you know what? We could tack weld that, be perfectly fine. You know, now that I think of it, I actually do have smaller boring bars here. So yesterday I made this bushing for the telehandler, but I realized that there is a grease fitting on the outside of the eye. So what we need to do is, first of all, put a groove right down the middle here like you'd see in a bushing normally. And then also, because the grease needs to go through that groove and we need to drill a hole, so that the grease goes through the groove and into here. What we need to do is make this fit that area better, because if we put a groove in here and we pump grease into that area, if the outsides aren't tight, then the grease is just going to come out here and not go inside. So as much as I hate to do it, I think what I'm going to do is just weld a couple beads around this and then turn it down again. I know that seems really sloppy to do that, and I probably should just start over, but this was a lot of machining to get to this point, and I don't see any problem with putting a weld around there. I mean, it's similar to line boring where you just weld around and then turn it down again, except we're doing it on the outside instead of the inside, but I don't really see that being an issue. I think the inside diameter is fine. It's got a nice slip fit, but the outside we need to basically get it a tighter fit just so that the grease doesn't come out around the outside. Alright, so don't laugh at my welding. It was just something quick to fill up. I wasn't even worried about what setting I was on, and I was using flux core, so looks horrible, but it'll do the job. Alright, so I know that's extremely crude looking, very unprofessional looking, but luckily we're not doing this for a customer. Luckily I probably will never do this for a customer, because this is just sort of for my own purposes. But I have a little groove in the middle for the grease to travel around. You know, there's a couple spots that I didn't weld enough, but this has got 2 thou over, so now it's a press fit. I'm probably going to throw it in the freezer for a little while, and then I'll heat up the area that it's going into. But I still do have to drill a hole in this. So I think I mentioned on the beginning of this video that these jaws right here do not open enough to put something bigger than, I think, 4 1/4, because they're not reversible. A lot of them are reversible so that you can bring this way out to here so you can get a pretty big bite on things. So what I ended up doing is ordering a new chuck, and I just got it, so let's go ahead and put it on. This is called a D1-4 chuck, and it's not that hard to change it out. And the new one that I got has reversible jaws on it. And I thought I was going to have to buy a used chuck, but apparently these are pretty popular, and this one's brand new. It's even got a certificate of accuracy. Okay, so to get this chuck off, there's 3 of these, and this has a cam lock system, so there's a stud that goes out, and it's got like a groove cut out of it. I'll show you, it's easier to show you. And they only go about, I don't know, half a turn or so. I've been learning a lot about this stuff, so I sound like I know what I'm talking about, and I kind of do, but this is all brand new to me, so. Okay, so once you take the last one off, you gotta be careful. It can kind of fall off. But basically, these studs, you can see the groove cut out of them, and in here there's like a cam that turns and it just tightens up right against those. Oh, that's heavy. So it should be self-centering. You can see that there's like a conical design to it. I don't know, maybe you can see it. See how it kind of angles up? So it should be self-centering. Okay, so as I'm moving, the needle moves 1,000, but as soon as I stop, it goes right back to 0 no matter where I am. So I would say that this chuck is pretty centered on here. And being that the jaws were already mounted when I got it, I'm assuming they will be pretty accurate too. So that's nice. I thought it would be a whole lot of work to get this thing dialed in, but If it's off, it's less than 1,000. Okay, I see how that works now. So the jaws themselves actually ride on a different part that gets locked in here. So you don't need to reverse the whole part by bringing it all the way out. You just need to unbolt the jaws from that part, and then you can reverse it. That's pretty cool. I don't know why the original one didn't have that. Maybe that's a modern thing. I like how that's like really firm in there. It's self-centering. The little tab and a little groove, they line up. Because otherwise you could end up with the jaws not perfect, which you really do need them pretty perfect. So this is a 3-jaw chuck, and all the jaws tighten proportionally, so they all tighten at the same amount at the same time. So a 4-jaw chuck has independent jaws that you tighten one at a time, and that's for grabbing things that are like uneven. So this one should always be accurate. It's supposed to be. But the 4-jaw, stuff like having these locks in here with the tongue and groove doesn't really matter, because with the 4-jaw, you're going to be adjusting things to make it centered. It takes a lot more time to do that. But you can work with things that are not perfect to start with. And there's a lot of guys out there that only run a 4-jaw. I definitely got to get a 4-jaw myself. It'd probably be a pain to change. I'm sure some guys just get 2 different lathes to run both of them, because it's going to be a pain to change the chuck when you need it. But for somebody like me, I'm not going to use this thing for production or even making parts for other people or anything. So I can just switch them out. But I would like the 4-jaw chuck just to be able to deal with parts that are a little bit off center. That's very wide. I should be able to get some big parts in there. I can see it's going to be annoying to do small parts with these reversed like this though. I just wanted to test it out. But I don't think you'd be able to do much work on something small like this. Oh, that's pretty cool. Oh, that's awesome. The lock for the jaws is connected in 3 different spots. See it moving up here? So it's not just one spot that you got to get as you're going around, which is kind of annoying because I'm always starting and stopping this thing to get it where I can unlock it. But this one has 3 different positions and they're all connected to each other. That's awesome. I'm loving this thing. This thing was only like $200 and something, maybe like $250. It's made by Shars. I think that's how you say it. S-H-A-R-S. Now I need a part to turn down. I suppose since I have the jaws reversed, I should probably get something flat and wide. Let's see what we can find. That's 6 inches in diameter. I was definitely not able to do that before. And this is barely even bringing these out. I got a lot more to go. Face cutting it right now to make it nice and even because this thing was way out of whack. The diameter was uneven and the face of it's uneven, so I'm just kind of facing it up, and then that way I can turn it around and it'll be true, hopefully. But if you don't understand how a lathe works, basically it's got an auto feed, so it feeds itself. This is the clutch right here, so that's off. See how it stops? That's on, so it feeds itself. The feed is adjusted with the speeds between these 2 gears right here. There's 2 sets of gears, and depending on which one you have it set on both of them, that dictates how fast this spins, which dictates how fast this goes. So this is the cross feed, and that's going relatively fast actually. And then if you put this lever up, then it feeds this slide right here. So right now I'm just making enough cut to make that nice and even on the front. That way when I turn it around and put it back in the jaws, it'll sit flush that way, plus the outer diameter will be perfectly round so it sits in the jaws right on the edge of the jaws. There's also this compound slide too, and that doesn't auto feed. Maybe some lathes do, but probably most of them don't. And this is for getting odd angles. You can angle this however you want. Like if you want to taper, you can put this thing all the way like that and then run it in, and then it would have a taper. But basically this one and this one are exactly 90 degrees from each other, and you can't change those. This one you can change to whatever you want. It'll actually rotate all the way around. So there's a lot of adjustments, a lot of different things you can do. And then this is the tailstock here. And basically this has got a quill that goes in there, and it has like a lock in it so that it can't move. And then if you go all the way back with it, it shoots the quill out, which this is loose right now. But you put this where you want, you tighten down this nut here, and then you can crank that out. So that's kind of the rundown of how this thing works. This is a stop, so if you have a place where you can't go that way anymore, like the jaws, this will stop you. You can set that wherever you want, and it'll stop the feed. So this right here controls which direction this goes, which direction that spins, so that you can either go in or out with the cross slide, or you can go right or left with this slide. So you can put that in one way, turn it and it's the other way, and then turn it the other way and it's neutral. and then this is high and low. That controls everything. So this spins relative to how that spins. If you speed up, it speeds up everything. It speeds up the feed and it speeds up the chuck. So they're always speeding up and slowing down relative to each other. And that's how you can get this thing to thread, because everything is super accurate within itself. So when you're threading, depending on how fast you're going, the feed is also going relative to that speed as well, so that you can speed it up or slow it down. It doesn't matter. The threads will stay the same. So I've been learning that running this thing on low speeds is quite a bit better. I've been pretty much on low the whole time, and you can only go up to 300 RPMs on low. So it's not quite fast enough for some things, but I'm a beginner, so for me it's fine. We could speed this up a little bit though. And now we're up to 250 RPMs, which if you have a piece that's big in diameter, like I would consider that pretty big. 250 RPMs is the spindle speed, which is on the inside. On the outside, it's going quite a bit faster than that. So right now, we're working towards the inside. So as you work on the face towards the inside, you could speed it up a little bit. But see, this thing is just still plugging away. Look at some of this stuff. Look at that. That's what you want to see right there. Big chips. This thing will take a pretty decent cut. But that chuck seems to be running pretty true right now. When we take that out and flip it around and put it back in, we'll know how good the jaws are, because it should be perfect. Just finishing that up right now. So now it might not show up that great on camera, but if you look on the inside where I already machined, that's running perfectly true right now. I mean, I don't know without a dial indicator, but it looks as good as it can get with my eye. And then the face is not going to be good because that was never faced to begin with. So I could face this again and then it would be good. I suppose I could do that just for kind of practice on bigger pieces like this. Look at that little tiny piece of steel. It's like, let's see if I can get that off. That is like the smallest piece of steel I've ever seen. The size of a hair. So I was trying to spin it as much as I can on the other side, and then I flipped it over and just got this last little bit that was in the chuck. It's, I don't know, it might be 1 thou off, maybe not even. But I could spend forever trying to match that up perfect. But now at least this piece is turned down true and straight and square and ready for whatever I use it for in the future. And it's probably still most of 6 inches left. I don't really have much of a use for a 6-inch piece, but maybe. But yeah, I mean, it's 5 7/8, so close enough. I'm sure I won't need exactly 6 inches. But that was kind of cool. Just turn this from like a raw piece of steel that was just like all kinds of out of shape into something that's perfect now and ready to put on the chuck and ready to use for something else. That's a nice little finish on it. I mean, I had a shiny finish on it at first, but I gotta mess around with the different inserts, different speeds and feeds to get different finishes. So now this piece can just kind of go back here and be ready for use for something else. What's neat about this is as I was turning it down, a lot of it didn't require me to be there. You just sort of set it up and let it go, walk away and do something else, and then come back when it gets close and then change it. It doesn't take a rocket scientist to realize that this thing is extremely dangerous if you're not careful. Loose clothing, jewelry, in general just being clumsy, putting your hand around here within 6 inches anytime it's spinning, that stuff will get you very, very hurt or even killed. Anyways, you guys get the hint. I got a lathe. I'm learning how to use it. It's definitely going to be used a lot on some future videos. The problem is I have a lot of things I want to use it for, but they're all going to be in another video. So I don't want to just go making a bunch of parts that'll kind of ruin other videos. As is, I already did the one part in the telehandler. That should have been in another video. But I also just didn't want to show up with it all of a sudden and just... I wanted to make a short video about it anyways. That way it's dedicated to just a lathe, and I'm sure there's going to be a lot of people in the comments that have worked these all their lives, maybe even this exact machine. This thing is probably from the 70s, which, believe it or not, is relatively new for a lathe, a manual lathe. I know that sounds like it's ancient, but some of the ones I was looking at were from like the 20s and 30s. So even the 40s and 50s, that's pretty ancient to me. But once you get up into the 70s and 80s, that's a relatively newer machine, because it wasn't too far after that they started going to CNC machines and stuff. So I wanted something that had gears, something that didn't have a giant belt on it that you had to change just to change the speed. So this was just new enough that it had all the features that I liked. And it's a southbend, so that's a pretty popular, I would say that's probably the most popular lathe brand that there is. I have an Aloris tool post, which is pretty popular too. I might try to do some harder stuff later on. Like, I do have a few cylinders that need to be re-rotted. I think that that's sort of an advanced thing to do, but I'd like to give it a shot. But I got a nice little arrangement of tools here. I got some nice steel, and like I said, that's only about a third of what I have. I have a whole bunch more, and I have a whole bunch more coming too. I ordered a bunch of stuff on eBay. You can order stuff like this on eBay for like $20 to $30 a piece, which is not bad. That's a lot of steel for that. That's like less than $1 a pound. And all different kinds of steel too. Like that's 1045. That's 1141, which I don't know what 1141 is. There's a lot of different steels that I have no idea. That's one thing I really need to learn a lot more about, is different types of steel for different applications. I think 1040 steel is a good in-between steel that you can use for pins and bosses, but then bushings you want to be a little bit harder. What would be really nice is if there was a way to actually tell what all these different types of steels are. Like, I remember back in science class in school, we had something that would scratch something, and if a certain thing would scratch this, but it wouldn't scratch that, then you knew the level was this. And I didn't really pay too much attention because I wasn't interested, but now I am, and I'd like to find out what different steels are, especially when you get random stuff from the steel yard that I don't know what it is, or like that pin right there, which that's a lot of material right there, but I don't know what it is. One thing that I really need for this, and I have not found one yet, is a steady rest. A steady rest is something that you mount over here for something that's longer, and it kind of gives it like an intermediate support. Like this right here can go on here to center whatever you're doing, but then you can't work on the face of it. So having a steady rest is usually just something that mounts right here, and it has like this circular part up at the top, and it has 3 screws that you screw in and out, and you keep working them back and forth until it's perfectly centered, and then it gives it support all the way out to here. That way you can come past it with your tool and do some work. So I really want to find one of those, but I have not been able to find it for this machine. I do have the part number for it, but it doesn't really bring up anything. So I may have to actually make my own, which it's not the worst thing, but that little notch in there is something that you really need like a mill to do that, and I don't have a mill. But speaking of a mill, I do want to get one. That is something in the very near future that I want to get, is like a Bridgeport mill. I figured this is probably first and it's more important, but that is almost as important and it needs to come soon. I'm not trying to set up a machine shop where I work on people's stuff all the time, but I would like the ability to work on my own stuff. So anyways, that's it for this video, guys. This was a little bit different, a little bit shorter of a video. The next video I have coming out is something that's been highly requested, and that is also a little bit shorter. I'm gonna try to keep these videos shorter for a little while, but keep them more frequent. Let's see if that changes the algorithm on YouTube. Maybe that'll help out. I don't know, we'll see. I got nothing to lose at this point. So that's it for this video, guys, and I'll catch you on the next one.